All right, guys, so I am about to go through the Chapter 9 test review, starting with the Section 9-2 test review. It's about a difference of two proportions. So again, notice these two problems are worth 2 points if turned in by Monday, which is the first day of finals week, and of course completed correctly. Okay, so the problem statement for number 1 says just before the presidential election in November 2016, a local newspaper conducted a poll of registered voters in a large city and found that 120 out of a random sample of 250 men. So I can already tell that's going to be important. It's a random sample, they're 250 men. Okay, so I'm thinking that the first sample N1 is 250. And I'm thinking that I know the first sample proportion, P1 hat, right? Remember, P hat is a sample proportion, and this is for the first sample, is going to be that 120 out of 250. Now, I probably want to make sure that I'm actually being asked about the people who intend to vote for Donald Trump, but I think I'm going to. I could always change it if I need to. And 132 out of a random sample of 240 women intended to vote for Donald Trump. Okay, so now I know that N2 must be 240, the 240 women, and P2 hat must be that 132 out of 240. Now, of course, I want to convert those to decimals, but just to highlight the information that I see from that problem statement, I've got that there. Okay, so part A says, is there convincing evidence? All right, that's already telling me that I'm going to be doing a hypothesis test. That's what I'm thinking. So is there convincing evidence that there is a difference? Ooh, all right, so I know that there must be, or that I'm thinking about that Chapter 9 material because I'm talking about a difference in the proportion of all men and the proportion of all women in this city. So there are my populations, all men in the city, all women in the city, who intended to vote for Donald Trump at the alpha equals 0.05 significance level. Okay, so we're going to do that 4-step process. So let's get started with that. First, we want to state, let's see, there are several things we want to state. The parameter is usually first. So that's going to be the first proportion minus the second proportion, P1 minus P2. Notice no hats here because these are population proportions. So this is the true difference. Difference. And I could say in men and women in this city, but I'm going to write that in the end to show how I'm going to subtract. So the true difference in proportions, or in proportion of those who... So notice, again, I'm talking about difference in proportion, and I'm skipping the population, but then I'm looking at what the proportion actually is based on. So of those who intended to vote for Trump. And again, it says men and then women, so I'm going to do men minus women. Right, I also made men the first sample, women the second sample, just because of the order they were listed in the problem statement. Okay, so now I also want to state my statistic, and this is what a lot of you forgot in that last homework. So please remember to state your statistic. It's not just P1, it's P1 hat minus P2 hat. Now, what a lot of you did in the homework is just state the individual sample proportions, but the statistic here is actually their difference. So we have to go ahead and subtract them. So we're doing 120 divided by 250 minus 132 divided by 240. And I could type it in just like that if I want to. So 120 divided by 250 minus 132 divided by 240. Because my calculator knows order of operations, I don't have to put parentheses around anything. It'll know to do the division before it does the subtraction. All right, I get negative 0.07. So my sample difference in proportions is negative 0.07. I can tell that the proportion of men is smaller than the proportion of women. If you're not sure about that, you can actually calculate what 120 divided by 250 is. It's 0.48, and then 132 divided by 240. which is 0.55. Makes sense. 0.48 minus 0.55 is negative 0.07. Okay, we also want to state the significance level, which they told us was 0.05, and finally our hypotheses. So our null hypothesis, let's see, first it's based on our parameter, so P1 minus P2. Our null hypothesis is always an equality, and for differences in proportions, we always assume that they're not different, so that they're actually equal to each other, or the difference between them is 0. Now the alternative is where we have to make a decision. It's again about P1 minus P2, but are we looking for them, for one proportion to be greater than the other, one to be less than the other, or for them to just be different? So it says, is there convincing evidence that there is a difference? It doesn't say that men are greater than women or women are greater than men. It just says a difference. So that's when we use not equal to 0. That not equal to tells me I'm doing a two-sided test. So when I find my p-value, I'll have to multiply it by 2. Except I'm going to use StatDisk to do this one, so I won't even have to worry about it. I will just have to make sure that the alternative hypothesis is entered correctly on StatDisk. Okay, so then we want to plan. So remember, this is called a two-sample. Let's see, it's a two-sample z-test for P1 minus P2. Remember, z always goes with proportions, t goes with means. And then we want to check our conditions. So the first condition is the random condition, and since we have two samples, we also have to check that they're independent. So it says random samples, and they are independent. Right? There's nothing to suggest that these men were matched or paired with the women in any way. All right, second condition, the first sample size of 250 is less than 1/10 of all men in the city. Okay, so it does say a large city. 10 times 250 would be 2,500. Any large city is definitely going to have more than 2,500 men, so that's met. And then N2 is 240, which is going to be less than 1/10 of all women in that city. Okay, again, 10 times 240 is 2,400. That's definitely less than all the women in a large city. So that condition is met, the 10% condition. The third condition is the normal condition. And since this is for proportions, I know it's kind of hard or easy to get the normal conditions mixed up. Definitely use that formula sheet from chapter 7 and 8. They both have the same things about conditions, so they can help you figure this out. For proportions, we check large counts. Okay, it's tempting to want to use the CLT here, but that only applies for means, not proportions. So I have to use large counts, and there are 4 different things we have to check. Okay, we have to check N1 times P1 hat. Now, this really is the number of successes in the first sample, or the number of people who intend to vote for Donald Trump. It should be 120, but we can check that if we're not sure. Remember, P1 hat is that 0.48, so 0.48 times 250, the sample size for N1, is indeed 120, okay? The other thing we have to check for sample, or for this first sample, is N1 times Q1 hat. So this is the people who don't do whatever it is we're interested in, right? 120 people intend to vote for Trump. How many people intend to not vote for Trump? Well, we could do 250 minus 120, 130. These two things have to add up to the total sample size. Or we could say 1 minus 0.48, 1 minus the sample proportion is 0.52, and multiply that by the sample size. So the proportion of people who intend to not vote for Donald Trump multiplied by the sample size is, again, 130. Either way is fine. We have to do the same thing for the second sample, N2 times P2 hat. Okay, so again, this is the people who intend to vote for Donald Trump from the second sample, which we saw was 132. And then N2 times Q2 hat, which is the proportion of people who do not intend to vote for Donald Trump, proportion of women, I should say, multiplied by their sample size, or just in general multiplied together. This is going to be the number of people who intend to not vote for Donald Trump. So again, I'm just going to subtract 240 minus 132, and I get 108. And those would, again, add to 240, so I know I've done it correctly. All 4 of those are all greater than or equal to 5, so that's how I know it's checked. A lot of you did not check this condition correctly in the homework, so be careful. Okay, so then we move on to the do step, And in the homework, you're required to do it by hand, but now we're going to use StatDisk. So you go to StatDisk, and of course, we're going to go to Analysis. I'm writing this down just so it's written. You don't actually have to write it down whenever you do your final exam. You can just say used StatDisk. So we'll go to StatDisk, and then let's see what our options are. What would make sense? Where'd my mouse go? We're going to go to Analysis up here. All right, so remember, are we doing a confidence interval or are we doing a hypothesis test? Well, we wrote out hypothesis, and they asked if we had convincing evidence. So we're doing a hypothesis test. So I guess I'll write down that that was our next thing we clicked on. Hypothesis testing. Okay, so then we have lots of options. Let's see, is it a proportion or a mean? That's one decision you have to make, or a standard deviation. We didn't even talk about those. We know it's a proportion. So do we have one sample or two samples? Well, we have a sample of men and a sample of women, so we choose proportion, two samples. Proportion, two samples. Okay, so now we're given this screen. Notice at the top it says the correct thing, hypothesis test, proportion, two samples. We need to make sure our alternative hypothesis is correct. And indeed, we have population proportion 1, or P1, not equal to population proportion 2, or P2. We want that, okay? Be careful on the test. It may be a greater than or less than, and you need to make sure to change it to get the correct p-value. Okay, that is the significance level we're using. So our first sample size is the men, so 250, and the number of successes, and the number of people who said they were going to vote for Donald Trump, was 120. All right. Notice it's not asking for P1 hat, it's actually asking for X1, the number of successes. So then sample 2, the sample size was 240, and the number of successes was 132. Those are the people who are intending to vote for Donald Trump. Okay, and then we just click evaluate. So notice you need to check your alternative hypothesis is correct up here. Let's see, we're not interested in the pooled proportion, although if you wanted to do this by hand, you could check your pooled proportion there. We see our test statistic Z. We could actually use this and use normal CDF or table A to check our p-value, but again, we don't have to. And here finally is our p-value. It's 0.12118. Okay, so I think you'll notice that if you do use this test statistic and find the left area, you'll get something like 0.06, but because this is a two-tailed test, again, because the alternative hypothesis is not equal, we will multiply that by 2, which gives us 0.12118. Now, I know a lot of you are confused because it also includes a confidence interval. Every significance level has a corresponding confidence level. If the alternative hypothesis is not equal to, if it's a two-tailed test, then it's really easy to find that corresponding confidence level. 0.05 goes with 95%. But if I instead wanted to say, I think the proportion of women is greater than men, so that the first proportion is smaller than the second proportion, and I evaluate this. Now notice, even though I kept my significance level the same at 0.05, it now says a 90% confidence interval, because an alternative hypothesis of less than is just a one-tailed test. And so I would have my 0.05 proportion on that left tail, 90% in the middle, and then 0.05 on the right tail as well, but I'm not worried about the right tail, so all 0.05 is on the left. Whereas with my not equal to alternative hypothesis, that 0.05 is split between the two tails, 0.025 on the left, 0.025 on the right, leaving 95% in the middle, or 0.95 in the middle. Okay, but when I'm running a hypothesis test, I don't care about the confidence interval. I just wanted to point out that connection between them. What I really care about, again, is this p-value. So what we're going to do in our do section is write down our p-value. P-value is 0.12118. That's it. That's all I'm going to do for the do section. You should write in used StatDisk. Right? Again, you don't have to write the steps for things you click on. I'm just doing that so that it's there for you later. But you do have to say that you use StatDisk if you just write down the p-value. All right, and then finally we need to conclude. So let's remember how we conclude hypothesis test. We start by comparing our p-value to the significance level. So since the p-value equal to 0.1218, sorry, 118 is greater than alpha equal to 0.05, right? You can tell 0.12 is greater than 0.05. Whenever our p-value is greater than alpha, we fail to reject the null, okay? It is never that we accept the null, but we fail to reject it, okay? So that means we do not have evidence against the null. It's not that we have evidence for the null, we just don't have evidence against it. So let's say that. We do not have evidence, I'm sorry, I should say convincing evidence, because that's what the problem statement says. We do not have convincing evidence that let's see, what was our null hypothesis? Put it into context. So the true difference, oops, I should have said the. Sorry about that, guys. So that the true difference in proportions, oh, actually, I could say that the true difference in proportions is 0, but if I really want to put this in context of the problem, I think I'm going to go back up and read the problem statement one more time. It says, is there convincing evidence that there is a difference in the proportion of all men and the proportion of all women in the city who intended to vote for Trump? So I'm going to say we do not have convincing evidence that there is. So that there is a difference. We do not have convincing evidence for the difference. It's not that we think they're the same. We just don't have convincing evidence to say there is a difference. So that there's a difference in proportion of all men and all, women in this city who intended to vote for Trump. Okay, that's our conclusion. So then part B, and I know this really threw you off in the homework. I apologize. I didn't mean for it to. In the notes originally, I did a problem on confidence intervals and then did a different situation for the problem on hypothesis tests. And in your homework, it would give you one problem statement, ask you to do a hypothesis test and a confidence interval. So I'm just going to show you how they kind of connect. So this says construct and interpret a 95% confidence interval for the difference in the proportion of all women and the proportion of all men in the city who intended to vote for Trump. I also like doing it this way because you can really see how these instructions are different from these instructions. Convincing evidence, significance level, that tells us we're doing a hypothesis test. This literally says confidence interval, that's pretty straightforward. But it could also say estimate the true difference, and that would mean use a confidence interval. Okay, so let's do it. When I go to do my 4-step process, I have just stated everything I need except for my confidence interval, right? I would normally state the proportion, the statistic, and my confidence level. But since I've already done it up here, I'm going to put C part A, but then with a 95% confidence. I don't have to rewrite what I've already written. So when you go to correct your chapter 9 homework, if you're looking to do that, you don't have to rewrite that all out. All right, my plan step is similar. I've already checked the conditions. I do not have to do that again. So again, I'm going to say C part A. But there is one different thing. This time I'm doing a 2-sample Z interval for P1 minus P2. Now, some of you on the homework got the idea that you've already done most of the things that you needed in state and plan in part A for part B. And so you just wrote, C part A, but you have to know that there are 2 different things. The confidence level has to be stated. That's not in the hypothesis. And the name of the procedure is different, right? This is an interval, not a test. Okay, so now we're ready to do the do section. And this is very similar to last time. We're going to go to analysis. And this time, instead of going to hypothesis testing, we're going to go to confidence intervals, which I think makes sense because this is a confidence interval. And let's see what would make sense to choose next. So we're going to analysis, confidence intervals, and then again, proportion 2 samples. Okay. So let's finish writing that down. Once again, you don't have to write this part down. Maybe I will even put it in parentheses in red so that you can tell this is just for us to later be able to look back. How did we get that? So let's see, this part right here in the do section, you don't have to write that down, but you do have to write down that you used StatDisk. Okay, so let's get that do section done. It's asking a lot of the same questions, except notice this time it asks for a confidence level, not a significance level. We did tell us to use a 95% confidence level, which is 0.095. So again, my sample for the first one, or my sample size for the first one is 250. The number of successes was 120. Sample size for the second is 240, and number of successes is 132. All right, evaluate. So now, once again, we're given the test statistic and p-value, but we don't care about those because we're looking at the confidence interval. So be careful. Whenever you're looking at a confidence interval, look at the results that give you the confidence interval. Whenever you're looking at a hypothesis test, look at the p-value. We're looking at this confidence interval, so it says negative 0.1583. So I'm going to go ahead and write down that confidence interval. Negative 0.15830, comma, and then the other part, the greater than, is 0.0183. 0.0183. Okay, so I like looking at this confidence interval because it really demonstrates to us that we do not have convincing evidence that the proportions are the same. 0 is a possible value here, right? It's not that we have confidence interval or convincing evidence that they are different, because 0 is within this interval. It's possible they are the same. But it's possible that the proportion of men is less than the proportion of women by about 0.15, right? That would be men minus women would be negative if the men are less. But it's also possible that the men are greater than the women by up to 0.018. Now, that's a really small difference, but it's still a difference. Okay, so please be careful. It's not that we have evidence that they're the same. We just don't have evidence that they're not the same. So let's go ahead and conclude. Now, in the 4-step process, you should always interpret your confidence interval. And then if you're also asked if you have convincing evidence, you can go ahead and state that. But you always have to include the confidence interval interpretation sentence. So that is that we are 95% confident that the interval from negative 0.1583 to 0.0183 captures the true difference in proportions, I'm going to abbreviate proportions, of men and women in this city who intended to vote for, I'm running out of room here, to vote for Trump. Very good. Okay. So I have my, we are blank % confident that the interval from blank to blank captures the true, and then my parameter difference in proportions in context of men and women in the city who intended to vote for Trump. Okay, so that is our side-by-side hypothesis, test, and confidence interval for a difference in 2 proportions. In the next video, we will move on to section 9-3.